All right, good evening. So we are going to be talking about Introduction to Trigonometry today. So I know some of the people weren't here in class, so we're going to go ahead and give you a little review of this thing. Okay, so trigonometry pretty much revolves around the study of six additional functions here. Okay, so if you're given a triangle, okay, we have our angle here. Usually this angle is going to be marked as theta. Okay, so this symbol here, this is called a theta. It's a Greek letter. I don't know how it sounds, but that's how we pronounce it. It's theta. And in trig and in geometry, like almost every angle is called theta. In algebra, every unknown is called x. Okay, so that's effectively your basic variable name for your basic unknown. Okay, and then what we're going to do is we're going to be looking at the angle, okay, and the side that is opposite the angle, we're going to call that the opposite side. And then the side that is next to the angle that lies along the same side, we're going to call that the adjacent. And of course, we have the hypotenuse being opposite the right angle, always the longest side. Okay. So the ratios that we have to memorize, okay, so we're going to go ahead and we're going to have our sine of theta. Okay, and that is equal to the opposite over the hypotenuse. Okay. The cosine of theta is equal to the adjacent over the hypotenuse. Okay, and the tangent of theta is equal to the opposite over the adjacent. Okay, the additional ones are the reciprocals. Okay, the cosecant of theta is equal to the hypotenuse over the opposite. Okay. The secant of theta is equal to hypotenuse over the adjacent. And then the cotangent, okay, cotangent of theta is equal to the adjacent over the opposite. Okay. Now, for your journey through pre-calculus, through your journey through calculus, you will write that you have the sign of something, okay? I don't care what that something is, but it's the sign of something. You're going to put in a theta here, you're going to put in an x, you're going to put in a t, but you're going to give sign some kind of an argument, okay? If you don't just like drawing the square root sign and not putting anything inside of it, okay, you can't do that. So your calculus teachers will brutally take off any points that you have if you don't give it an argument. Okay, so if you just say sign and leave it alone, like I think you're having a religious discussion with me rather than talking about a trigonometric ratio. Okay, so always give your trigonometric ratios some kind of argument. Your calculus teacher will be a lot happier with you. You will be happier with you because your grades will look like they deserve to be up there. And then we can go for that. Okay, there's a abbreviation. There's a mnemonic. There's sine, which is opposite over hypotenuse. Cosine, which is adjacent over hypotenuse. Tangent, which is opposite over adjacent. Okay. Usually people abbreviate this as SOHCAHTOA. I don't really use this mnemonic. If you go ahead and Google this and put it on Facebook for SOHCAHTOA, you will see some very, very cringy high school teachers going off about SOHCAHTOA and screaming it at their classes. So you'd all be better off if you never saw that. But if you need help remembering what these trigonometric ratios are, I'm sure that will soothe that into your brain for now until you pass away someday. Hopefully a very, very long time. Okay, but you will remember this. Okay, it is one of those things you have to remember. Okay, so and I'm just going to talk to you like you have this. Okay, so that's what we have for sine, cosine, and tangent. And then I always when I do the original parts of this, when you introduce sine, cosine, and tangent, I always write it in this layout so that the trigonometric ratio and its reciprocal lie across from each other. And that's what we can do with that. Okay, so I apologize for the fact that the first problem is not a very well written, very nice problem. But all we're going to do is have you go through sine. Just going to have sine is going to be the x over the y over the r. Why are they getting x's and y's? You didn't do anything like that. Okay, So what we usually start with is something called the unit circle. Okay, so pretend that's rounded. Okay, we have an r is equal to 1. Okay, and what we're going to do is we're going to figure out what this point is. So if I look at this point, right, there's an xy here. And what the sign is doing, it's measuring this spot right here, this vertical distance. So that would be the y coordinate over the length, the r coordinate. Okay, the r length. So that's how we're coming up with sine of this angle here, this interior angle here. The sine of theta is equal to the y over r. Okay, when we get to cosine, do the same kind of thing. Okay, we're going to have a circle. Pick a point on your unit circle. It doesn't have to be on the part. Okay, again, pretend that's round. So what we're doing here with this angle, okay, what we're doing with cosine is we're measuring the, again, this is x, y value. This value here is x, so we're going to have x over r, okay? And then the cosine theta is going to be x over the r, okay? I would always prefer to do this with triangles rather than with circles, but that's okay. If you want to do it with circles, I'm not going to have an issue with it. I tend to teach it with triangles because that's how I was taught, and later on when you go into physics, you will be doing a lot with triangles, and I just think it tends to, trig tends to lend itself more to physics than it does to calculus, but it does both. So it doesn't really matter which way you want to think about it, just go with it that way. So cosine, that's the adjacent, that's going to be the x part, because that's the adjacent part over the r. Okay, tangent is going to be the y part over the x, the opposite over the adjacent. Okay, and then the cosecant is going to be r over the y part, because that's the opposite, it's the reciprocal of sine. Okay, and then the secant is going to be r over the x. Okay, and then the cosine is just the reciprocal of the tangent. The tangent was y over x, this is x over y. Okay, so that's what we have for all of that. Okay, now we'll go ahead and check it. Boom, gray. Every year, and I would recommend memorizing this with the triangles rather than with the x's and the r's. If you're a huge fan of the unit circle, you can do it with the x's and the r's, and that's fine. It'll work exactly the same way. But every year, I always have students who fail to memorize the trigonometric ratios and what they mean, and they lose a lot of points just because they can't remember, sine is opposite over hypotenuse, and you don't want to be that student. You don't want to put yourself into that position. So you do want to memorize the circuitor thing. And whatever tool lets you do that, please do that. Okay, it's just not. I don't want to take points off that you didn't remember this. I will, but you really want to have that committed to memorize. Okay, committed to memory. Okay, so we'll go on. We'll go to this next one. Okay. Now, okay, this is more unit circle stuff. All right. So when I'm going to go ahead and draw a unit circle, we're just going to put a random point on here. So I put a point in the first quadrant. So if I want to get with my x and my y here, right, this y ordinate, right, it's in the first quadrant. The y ordinate, right, is a positive number. R is always a positive number because it's a distance. So we're going to get a positive number over a positive number. That's positive. So sine is positive in quadrant 1. Okay, sine of any angle is positive if you're in quadrant 1. Okay. Sine will also be positive. So again, we draw a little circle here. Okay, so I draw here's my angle. Any ordinate I happen to pick here, right? Since we're above the axis, right, the y part is going to be positive. But since we went backwards from the origin, the x part is going to be negative. So we have a negative x and a positive y. So if I want the sine of this angle, we're going to have a positive number. That was the upper part, right? Opposite part of this triangle, divided by the hypotenuse. Okay, and technically we are looking at this angle, but the ratio is going to be the same for this, what they call reference angle. Okay, so we can look at it from here. We could look at this piece over here. But either way, your y part is going to be positive. Your r part is going to be positive. So we have positive with positive. So sine is also positive in first quadrant. So sine theta greater than 0 if quadrant 2. Okay. How about for quadrant 3? Well, for quadrant 3, we have a point down here. Okay, technically the angle we're looking at is going to be something like that, but we're going to use reference angle. Okay, and reference angles always go from the terminal end to the nearest horizontal. Okay, always to the horizontal. Don't go vertical. We're not going over here. Always to the horizontal. So that's our reference angle, right? So if I look at the sine of this thing, right, that's going to be the opposite value. And if I look at the point here, right, we're going to have a negative x and a negative y. Okay, that's our ordinate. So if I look at the sine of this angle, right, the opposite side is going to be a negative ordinate divided by r is always positive. Okay, r is always a positive number. So we have negative over positive. So sine of this angle is going to be negative number if quadrant 1, 2, 3. Okay, and then last one. Okay, we have our circle. A point here. Okay, so if I pick any point in the fourth quadrant here, the x part is going to be a positive number. But since we're below the axis, right, all of our y parts are going to be negative. So the angle I'm looking at is this guy right here. This is my theta. Okay, so we have sine of theta, okay, is going to be a negative number divided by a positive number. That's going to be a negative number. So sine theta is going to be a negative number in quadrant 4. Okay, so this is a mnemonic that I actually do like. I will use it, and it tells you like what are the signs, the SIGN, right? Not the SINEs, but the sign of any trig ratio. They are all positive first quadrant. Only the sine and cosecant, okay, is positive in the second quadrant. The tangent, because it's going to be negative over negative. Okay, the tangent and technically cotangent are positive in the third quadrant, right? Because both your x's and y's are negative. It'll be y over x will have negative over negative, so that'll be positive. And in the fourth quadrant, we have positive x, right? That's going to be adjacent, and have cosine that's positive in the fourth quadrant. So the mnemonic I use for this is all students take calculus. Okay, so that's how you tell which trigonometric ratios are positive in which quadrant. Okay, so all students take calculus. All right. When I go back to my Alex piece here, if I can. Okay. What are they asking us to explain? Fill out the tables for the appropriate sign, and then what are the signs for each one of these? Okay, so quadrant 1 for sine, quadrant 2 for sine, quadrant 3 negative, quadrant 4 is negative. Okay, I like that. Cosine, cosine is positive in the first quadrant. It's also positive in the fourth quadrant. It is negative everywhere else. So we can say negative and negative. Okay. For the tangent is positive in the first quadrant and positive in the second quadrant, third quadrant rather. It is negative everywhere else. Okay, yes, it's delightful. It's filling all these things are. This is what we have. Okay, so this is cosecant. Cosecant is almost the same as sine. Okay, it doesn't change the SIGN of the ratio depending. So in the first quadrant, it's just positive. The student's part, that's positive in the second quadrant, and then everywhere else it's negative. Okay, so just flipping the reciprocal doesn't change the positive or negativeness of it. Okay, secant, that's reciprocal of cosine, so it's positive in the first quadrant, it's positive in the fourth quadrant, negative everywhere else. Okay, and that's just how you're going to fill out this table. Okay, cotangent was positive in the first quadrant. It's also positive in the third quadrant. Okay, it's negative everywhere else because one of the x's and the x's and the y's, one of those two is going to be negative in those two quadrants. In the third quadrant, they're both negative. So we get away with being able to not have to worry about that. Okay, hopefully that'll work out. Hooray, we got all green checks. And it looks like we're pretty good. Okay. And that's just what they're having us do with this kind of a problem. And then we're going to get into something a little bit more difficult. So just to give us a taste of what's going on, and I'll stop the video after this one. But they're saying the tangent is positive. So the tangent theta is greater than 0. So right now, that means we could be in quadrant 1 or in quadrant 3. Okay. But they're also saying that the cosecant theta is negative. Okay. So remember, it's all students take calculus. The cosecant and the sine are reciprocals. So the cosecant and the sine would both be positive here. But they're saying that, so right now, okay, I know that tangent is positive. So we've got, it could be in the first quadrant, could be in the third quadrant. But since they're telling me that the cosecant is negative, well, the cosecant is negative everywhere except quadrant 1 and quadrant 2. So what we're doing here is we're saying, aha, this has got to be quadrant 3. Okay, because cosecant is negative, tangent is positive, the cosecant is negative, it's quadrant 3. Okay, so we're going to go back here and say angle theta must be in quadrant 3. Okay, and we'll check. And these are builder exercises. These are builder ideas here. I'm not going to necessarily ask you guys a quiz on the specific idea, but I will ask you, like, where is this angle? Okay, given that you have this information, where would this angle be? So we go through, do more of that. Okay, so I'll stop us here and I'll pick back up for this for the next one. Okay, so thank you very much for tuning in. I will see you in the next video.